Okay, so welcome to dividing radicals. This is kind of like multiplying radicals, as you could probably imagine, in the sense that your outside numbers, your coefficients, can get divided together, and your radicands can get divided together. Those are the inside numbers. So outsides go together, insides go together. We're just not multiplying this time. We're dividing. You cannot cross over between the two. Outside's got to stay with outside numbers. Inside numbers have to stay with inside numbers. Okay? So you can't intermix them or anything like that. Just make sure they stay separated like that. And other than that, you're just doing some division. So I wrote out a few steps for you. I'm going to go through them each time. Make sure you check for perfect square radicals first, because the worst thing in the world is when you start simplifying a radical and you go through all these steps just to realize in the end that, oh my God, that was a perfect square. I didn't need to do all that crap. So make sure you're checking for those perfect squares, okay? And if you have one, take care of it. Step 2. After you've checked for perfect squares, you can divide or reduce radicands. Those are the numbers inside. So if the two numbers are both in a radical, they can divide together or reduce like a fraction. When I say reduce, I mean if you have 2/6, you would call that 1/3. You can still do that with a fraction, even if it's under a radical. It still works the same way, okay? So the fact that these are inside of radicals doesn't change the way that fractions work, okay? And then step 3, simplify any resulting radical at the end. Make sure it's in simplest form. Okay, so for example, number 1. That's step 1 that says check for perfect square radicals. Boom. Right off the bat, we've got 2 perfect square radicals. So square root of 49 and then the square root of 100. So this will be 7/10. That's it for that one. Can't reduce that anymore, by the way, because 7's prime. Number 2, we have the square root of 8/32. Now 8 and 32, neither of them are perfect squares. So step 1, check for perfect squares. There aren't any here. So I'm moving on to step 2. Reduce the fraction if you can. So 8/32. Pretty sure that 8 divides into 32. It does, 4. So this is going to reduce to, God, I'm so horrible at making that symbol when it needs to be tall, 1/4. Okay? And then what I have here, if I split them up, square root of 1 and square root of 4, by the way, you can write it this way or this way. They're the same thing. Okay. Anyway, square root of 1 is 1. Square root of 4 is 2. So this one's just 1/2. No more radicals, because I ended up having perfect squares in the end. Number 3. We have the square root of 3/16. Only one of these is a perfect square, so I can split them up like this again, like I have been doing in the last 2 problems. And then I can say to myself, hey, look, that bottom one, the square root of 16, is actually 4. So that's going to be a 4, but the top has to stay radical 3. So sometimes you have a radical in your answer. Actually, most of the time you will. And that's totally fine. So square root of 3/4. Number 4. Square root of 10 over the square root of 45. So neither of these are perfect squares. They can reduce. They're both divisible by 5. So if I treat it like one great big fraction, 10/45, I can actually reduce that to 2/9. And then what I actually have here is a square root of 2 and a square root of 9. And we all know that 9 is a perfect square. So square root of 2/3. Okay. Number 5. We have the square root of 12 over the square root of 36. So I can do one of 2 things here. I can reduce them because they're both divisible by 6. Or I can realize that my Apple Pencil is dying. Sorry. Or I can realize that bottom one is a perfect square, square root of 36. So we're going to do the square root of 12. The bottom square root of 36 turns into a 6. Now, most people would stop here, but here's the problem. The square root of 12 is not simplest form. I want you to look at the other 4 examples I did, because you're probably saying, hey, Miss Underwood, you didn't do that in the other examples. Well, that's because I know that the square root of 3 can't be simplified because 3 is prime. There's nothing that divides into 3. And over here, same thing with 2. There's no perfect square that divides into 2. But for 12, 4. 4 is a perfect square that can divide into 12. So we need to make sure, let me go up here to the steps and show you what I mean. Simplify that resulting radical. So once you're done with all the dividing and stuff, you still need this in simplest radical form. Okay, so if it's not on a test, you're probably going to lose a little bit of points. So we're going to split this apart into 4 times 3. It was still over 6. And this turns into 2 radical 3 all over 6. So believe it or not, I'm still not done yet because remember outside numbers can go together and inside numbers can go together. Outside I have a 2 over 6. Neither of these are in a radical, so I can reduce 2 over 6. So it's going to reduce to 1/3, and then that radical 3 stays where it was. There you go. You don't need that 1 there, honestly. You could just say radical 3 over 3. Same thing. Okay? Number 6. Again, I don't have any perfect squares here, but I know that 3 can divide into 96. So 96 divided by 3 is 32. And then there's no more denominator. Okay? So square root of 32. Now I need to put this in simplest radical form. 32 can be divided by 16. So we're going to split this apart into a perfect square, 16, and then a non-perfect square, which is 2. So this is 4 radical 2. Okay. A few more. All right, number 7. Again, this little 7 out here by itself, don't die on me, pencil. I got a few more minutes. This is a coefficient. Ignore it for right now. Inside of the radical, we have 108 and then 6. Can 6 divide into 108? It can. You get 18. So what I need to do is leave the coefficient and then do the division. 108 divided by 6, 18. Notice how the 18's in a radical because the 108 and the 6 were in a radical. So this is pretty much done. I just need to make sure it's in simplest radical form. So leave your coefficient. 18 can split apart into 9 times 2. 9 would be my perfect square. Turns into 3. Multiply it by the coefficient. So 21 radical 2. Number 8. Again, inside radical, I can simplify. So we're going to leave our coefficient, which is a 3. And on the top, 5 divided by 5 is 1. 45 divided by 5 is 9. So 1/9. That 5 over 45 reduces to 1/9. Okay? So, square root of 1 is 1. So 1 times 3 is just going to be a 3. And then the square root of 9 is 3. So I have 3 over 3, which is just 1. This one was an interesting problem to do. All right, 2 more. All right, 15 over 27. Both divisible by 3. Okay, and then 4/3. So outside numbers 4 and 3 stay together. Inside numbers 15 and 27 stay together. So I'm going to reduce where I can. 4/3 doesn't reduce. 15 over 27 does. So we'll leave the 4 and the 3, the 4/3. 15 and 27, both divisible by 3. So 5, 9. Okay? Square root of 9 on the bottom. Here's my perfect square. It turns into a 3, gets multiplied by the coefficient. So this is 4 radical 5. And then on the bottom, 3 times 3, 9. So I want to look at these coefficients and make sure I can't reduce them. 4 times 9. 4 times 9? Oh my God. 4 divided by 9. Can't reduce 4 over 9. Okay, so that's done. Let me put a box around that. Answer. Okay, last one, number 10. Coefficients. If you can reduce them or divide them, you will. Looks like I can. You can divide 10 by 2. So I'll come back to that in a second. And then 48 divided by 3. Same idea. So 10 divided by 2 turns into 5. And then 48 divided by 3 is 16. 16 is a perfect square. Look at that. So really what I have here is 5 times 4. That was an easy one. Okay, so that's the basic gist on how division works with radicals. In the next video, I'm going to show you what rationalizing the denominator is. So make sure you watch the next